So we continue study optimization problems. Well, our first problem will be following. We have a parabola, and so this is a picture. Y equals x squared. It opens upward. And I also a strict line, for example, y equals 1/2 of x minus 1. Right. So it's not connected. We want to find a point on parabola which is closer to the line. Okay. Find the z point, probably there's only one point here, on the parabola, okay, which is closer to the line. All right, now how do we solve this problem? First of all, we have to make sure that the line segment that connects the point to that point must be perpendicular to each other. Why? Because if it's not perpendicular, then there's another one shorter than that. Okay, so this is must be perpendicular to each other. Okay, we needed to find a distance function. Okay, among all those lines perpendicular to the line. Okay, and then you should get a function of one variable. Then you find the minimum value of the function. So the idea is the equation of the line will be in the form y equals -2x, okay, plus a constant. Okay, so the parameter may be a constant k. So then you have a 2 intersection points, right? And then you find the distance between 2 intersection points. This is the way we solve the problem. Okay, so you have a family of curves, right? Family of straight lines, and you measure the distance between those 2 intersection points. Okay. And you find the value of the k such that it has only one. The distance is minimum. So let's find that the intersection point was the line. Okay. Well, let's see what was the best way to do. Now, clearly on the picture, right, there is a point on the parabola which is closer to the line. Okay, how do you find it, right? First, I have to recognize, you have to see that this the two cluster points must form the line perpendicular to the given line. Okay, so the slope is -2x. Okay, So let's find let's find the two intersection points. Y equals x squared, y equals negative 2x plus k. Okay. So you should get two solutions, but xk equals negative 2x plus k equals 0. Xk plus 2x minus k equals 0. So you get two x values. So x is going to be plus, negative b, okay, plus minus b squared minus 4ac. So plus 4ac, okay. It's k. So after you simplify, it's going to be plus minus square 1 plus k. Okay. So we have to choose a point x2. It's plus 1 plus k. Okay. So that is x1. Yeah. So the point on the left hand side, the other one, why there is 2 points? Because if you extend this line, you get another intersection point. So this is a y1 is going to be x1 squared. So those are the coordinates of the point on the parabola. And now you also have to look at intersection point on the half of x. Y equals negative 2x plus k. Okay, so you look at this intersection point, then you get half of x minus 1 equals 2 negative 2x plus k. So when you multiply both sides by 2, then you find out it's 5x equals 2 plus 2k. So x is going to be 2 plus 2k over 5. Okay, so once you find the 5, this is x2, right? And then y, the y coordinate doesn't matter which one you're going to use. You can use let's look at 5k. Okay, so you can use any of the equation, half of x2 minus 1, so be 10 2 plus 2k minus 1. Okay, so that's going to be 10 2k 2k minus 8. Okay, you can, of course, you can simplify it to k minus 4 divided by 5 again. Okay, those are the points. Okay, so you have 2 points. So distance function is going to be square root of x1 minus x2 squared, y1 minus y2 squared. Okay, so let's see if we can get. We already have the equation over there, right? So the difference of x1, x1 is 1 plus k here. x2, okay, and the y1 is going to be negative 1 plus k squared, right? Minus y2. All right, so as you can see that, well, probably not able to solve the equation. Solve the problem. This is a distance formula, depends on value of k. Okay, then you just need to find out. Now, in order to find the minimum value of the distance function, you just need to look at this function called f of k. If f of k has minimum values, then square root of f of k has minimum. The reason we want to do that because we don't want to use trying to get rid of radicals first. So it's negative 1 plus k. It's minus 1/2, right? What do we? This is x2. It's a 5, yeah. So half of 2 1 plus k squared. Okay. So just have to find as a x value. Find as a critical value. Yeah, if you can find the critical value, you can determine the value of the k. I'm not sure we can do this. I just pick up the problem. So at least this is the idea. You set up the equation, and you find the function represents the distance between 2 points, and this function depends on one parameter. Then you find the critical numbers. Okay, so this is x k equals 0. So well, I don't think we're able to solve it. So use a computer, we can do that. Okay, just find the derivative, and you get an estimate variable k. Then you use a k value to determine the 2 points. Okay, then you can get exact location. So unfortunately, this is a very bad function. Yeah. Okay. Yes. But the idea is clear. You know, you describe the distance function using one variable. Could be x, could be y, could be another parameter. In this case, it's constant k. Then you get a function of k. Then you find the limit. Now you can see that the limit as k approaches positive, negative, infinity k, and I'm pretty sure this is going to be plus minus infinity. That's the reason it must have a absolute minimum value. The reason is when k goes to infinity, because this is both a square here. So so the function will be like that, you know, goes to both sides. So definitely there is this is a variable k. Okay, this can be z equals f of k, and it must have a minimal absolute minimum value. Okay. Yeah, we are better like we get a very bad function here. I'm going to pick up the problem from this book. They are carefully selected these problems, so we are able to find the derivative. Okay. Okay, so here's the question, number 23 from the problem. So here's a picture. Find the point on the ellipse. The ellipse is 4x squared plus y squared equals 4. Okay, that is, so maybe we have more than 1 point. So that is farthest away from the point when the 0. So let's look at the picture. Parabola, the ellipse is going to be x squared plus y squared over 1/2 of square equals 1, right? Which side is going to be 1/2? Okay, no, just 2. Another 1/2. So it's 2 squared and the y squared. Okay. So when x equals 0, y is 1 and 1, 2, right? Negative plus minus 2. When y is 0, x is plus minus 1. So this is an ellipse. Okay, and this is a point when 0. We are looking for 2 special points, and they are so that the length of this segment has the largest possible value, and that's the distance, right? So we're looking for the points on the ellipse. They are farthest away from the given point, right? So the idea is simple. So here's coordinate x and y, right? First of all, we know that x squared plus y squared over 2 squared equals this, right? Then the distance function, d, okay, is going to be x minus 1 squared plus square root of x minus 1 squared plus y squared, okay, y minus this. So that is the distance d, okay? And you can see that this is an interesting function. That d is the smallest possible value for d is 0, okay? The largest possible value we don't know, okay? We don't know yet. So you get a function of x and y, but x and y are related because this is a point on the ellipse. So when you look at up here, see y squared equals 4 minus 4x squared. So you put into here, you will get x minus 1 squared plus 4 minus 4x squared. Okay. So we want to find the x such that can x be arbitrary? I don't think so. When you look at the x value, this is between -1 and positive, right? Clear, right? X cannot be arbitrary, okay? Because this must be positive or negative, no negative. And so x squared is less than or equal to 1. So we are going to look at this function. So I let f of x, that's trick. We don't directly work on the radicals. So now it's polynomial, okay? So let's multiply this out. I get negative 3x squared minus 2x plus 5. Okay, x is between negative and positive. So let's look at the value of f. When x equals 0, this is going to be 5. Okay. When well, we don't know that. When x equals 1, okay, more interesting. We'll look at 2 endpoints. When x equals 1, this is 0. Not surprised because the distance between two identical points, two same points will be 0. Okay. But so when f of -1, then it will be -3 plus 2 plus 5, which is 7. So it's 4. Okay. All right. So let's take a look at the function. I'm going to use a z equals f of x because the y variable has a special name. This is x, right? And this is -1. That's a positive 1. All right. When x equals -1, the z value is going to be somewhere here. And -1 and 4. When x equals 1 to 0. So probably the function looks like that, okay? Yeah. Because of graph, it's a parabola, up and downward. So there's somewhere there's a highest point. Okay. So we want to find the maximum value of f of x. So that gives you the maximum value of the distance. Okay, and so let's look at the possible critical numbers in the middle. So when the derivative is going to be -6x minus 2, which is 0. Okay. So you get x equals -2 over 6, which is in the 1/3. So somewhere here, I'm not surprised. This is the critical number. The critical number. So in order to find the absolute maximum value of this f of x, you just need to compare the 3 different values, right? F -1/3 is going to be -3 times -1/3 square minus 2 here, -1/3 plus 5. Okay. So this is going to be -1/3, right? 1 over 9 times 3. And that's plus 2/3, right? So it's 1/3 plus 5, which is larger than 5. Okay, it's larger than 5. Okay, you can say simply like this. As this is greater than 5. This is largest possible value. So clearly, it is this is the absolute maximum value. Okay. So we know that if we get the x value, right? Yeah, you get the x value for which the function has a maximum value. Then you also can determine the y value. Y value is going to be 4 times 1 minus x. Okay, so when x equals -1/3, y is going to be 4 1 minus x squared. Okay, it's 4 minus 1 minus -1/3 squared. Okay, it's going to be 4 times 1 minus 1 over 9. It'll be 8 over 9. Okay. 32/9. Right, so we get the point, this is a y square, right? Sorry for that. It's a y square. So you can, the y value is going to be plus minus square root of this. Okay, if I have to get simplify a little bit, I think it's a 4/3 square root of 2. Okay. All right. So now we get 2 points on the ellipse. That's 2 points. One is here, and the one is here. It's going to be -1/3, -4/3 square root of 2. Okay, -1/3, positive 4/3 square root of 2. So those are the 2 points on the ellipse. It gives the maximum distance between the point and the given point. Okay. So using mathematics, you can get exact location where the point was the maximum distance from the given point was coordinate 0 and when 0. Okay, so the idea is you use the distance function, describe the distance function in one variable only, and you find the maximum value of the distance function. But it's better not to use a square root of this function. Just let fx to be the function inside the radical. As long as that one has maximum value, then the square root of that function also has maximum value. So, but the computation will be much simpler without the radicals. That's the trick. Okay. All right. Our next problem is also about the ellipse. We want to find the area of the largest possible rectangle. When we say largest, it means in the area, okay? That can be inscribed in the ellipse. Now we're trying to get the general formula. So x squared over a squared, y squared over b squared equals 1. Maybe the ellipse looks like that, depends on the value a and b. In this particular case, for example, a is greater than b, okay? So so 2 foci is on the x-axis. Okay. And then we want to find a rectangle which has the largest possible cross-section. Okay. Sometimes you have to cut the material. So cross-section is ellipse, and we want to cut 4 sides to make a rectangle, cross-section rectangle, right? Use a machine. Then you have to calculate, what kind of a rectangle, what kind, maximum, what is the area of the largest possible rectangle? You want to determine the dimension. Before you do the cutting, okay? So you want the cross-section of the rectangle has the largest possible area. That's the idea, right? So all we have to do is find the coordinates of that point, okay, in the first quadrant, right? Then the problem is simple because first of all, x and y satisfy the equation for the ellipse, okay? Area, you have to write as the area formula. Area is going to be, first of all, x times y, right? But x times y have 4. You have to multiply 4. That is total area of the rectangle. Okay, so here clearly x should be greater than or equal to 0, y is greater than or equal to 0. Okay. Now, how do we solve the problem? We want to change it to the one variable, not two variable, right? We have the quantity A depends on 2 variables, but those 2 variables are related by the equation. So you can solve for y in terms of, you can solve y in terms of x. And the y is going to be, y will be going to be plus minus. Okay, but our y is positive, so you just use the positive sign, okay? So since y is positive implies y equals b of that. All right, so now the area formula is going to be 4 times x, 4b, yeah, there's b here, and the 1 minus x squared over x squared, a squared. So what is x? X is greater than or equal to 0. I think x cannot be larger than a. So that is a domain of the variable x. All right. So when x equals 0, area is 0. That's a special case. When x equals a, area is also 0. For x between 0 and a, we know a is positive. So the graph looks like that. Okay. So I want, it has absolute maximum value, clearly. The question where this is where's the critical number. Okay. All I have to do is just find the derivative. Yeah. So when you work on the test or the quiz, I really want to see this part. Okay, this is a key part. I check that. Express area in terms of one variable. Okay. The next part is just find the derivative. It's not our main focus. You know, you can find the critical number, you can find the derivative, right? Find the derivative first, then find the critical number, then find the absolute maximum value somewhere between. It occurs somewhere between 0 and a. So let's differentiate. Okay. Well, how do I define? How do I find the derivative? It's product rule, right? Product rule a. Let's rewrite. Write it in this form. I'm going to find the derivative. Apply the product rule. So I get 4b 1 minus x squared over x squared, right? Then the derivative of second term, which is half of 1 minus x squared over a squared, 1/2 minus 1 negative 1/2, and then don't forget it's 2x over a squared, because the derivative inside you get 2x and denominator is a squared. All right, so you have to simplify it. Take the common factor out. Okay, this 2 canceled out. And maybe you also take this part out. So you get 4b 1 minus x squared a squared negative 1/2. And this will be just x squared over a squared. Okay. And the x 4b is gone. So it's negative. I think it's negative x squared over a squared. Yeah, so that's it. So don't worry about the first part, the second part, right? The second part, this is going to be 0. 1 minus 2x squared over a squared equals 0, right? So x squared equals half of a squared. So that means x is going to be plus minus. Well, we only consider positive x. So so x is going to be positive. All right, so you find there's one critical number, only one critical number. X is between 0 and a, right? So there's only one critical number. We want to find the area as large as possible rectangle, right? So in this case, okay, so a must have a maximum value when x equals a over square root 2. That's clear enough because a has 0 value at the 2 endpoints. Okay, and in this particular case, y is going to be what? Y is going to be, let's go back. Y is going to be b times right? So let's see what is y. X squared is going to be, x squared is going to be a squared over 2. So a squared cancelled out. Okay, it's pretty nice. So x and y, we get the values. Okay, and the area in this case, the area is going to be 4x times y. It's 4 times a over square root 2 and b square root 2. So the answer is 2ab. So this is the largest positive value of the rectangle inscribed in the ellipse. Now, what is the area of the ellipse? Do you remember that? The area of the ellipse is going to be a times b times pi, okay, which is larger. That's what already did it, right? Which is larger than the area of the rectangle inscribed in this ellipse. Yes, the area of the ellipse. Yes, the area is going to be is going to be ab times pi. So this one area is going to be 2ab. Okay, I'm going to do the next problem. It's a cylinder. Okay. We know that the height is h, the radius is r. Okay. We don't give a specific value. You don't need analysis. Okay. Find the largest possible volume of the cylinder inscribed, circular cylinder inscribed in the cone. Okay. Find the volume of the largest circular cylinder inscribed in the cone. Okay. So this is a cone. There are many ways to describe. This is a cone. Are you able to determine the dimension? Okay. If this is radius r, this is h. So can you express I and the h for which the corresponding cylinder, circular cylinder, has the largest possible volume? Yeah. Can you do this geometry now? Yeah. So step one, you have to express. The idea is that first find the relationship between I and h. Okay. Second, describe the volume form, right? The volume is going to be pi r squared h. So this should be this should have a maximum value, yeah, because this is volume formula. So can you find a relation between I and h? Find this. Right? Can you use a geometry to find the, capital H and capital I is fixed. I can say this is a 20 feet or 10 feet. Okay, and clearly I and H are related, they're not arbitrary. Okay, when changing the radius for the cylinder, you change the height for the cylinder. Okay. So this is a cross section. Here's R, this is H, right? And therefore, this is going to be H, capital H minus little h, right? This is capital R. So use a similarity of triangle, capital H minus little h over capital H is R over little capital, right? Because those two triangles are similar. So then I think I just needed to express I in terms of H. So I put it into the formula here, then the volume is going to be pi R squared so we get a polynomial in H. So what is the smallest possibility for H is 0. The largest possibility for H is capital H. Okay, and then now it's clear when it has maximum value. Just differentiate, right? And that can be H squared minus, you put H here minus 2, H squared plus H cubed. All right, so find it, yeah, clearly this will be 0 when H is going to be 0 or capital H, okay? So if you draw the function and you still get yeah, the volume is always positive. This is H. So somewhere here in the middle, there's a maximum. The volume has maximum value, right? So find out. Just find a critical number. So derivative of V with respect to H. Okay. So this is the quadratic function. We can solve it. Okay, let's set this to be 0. Little h is going to be negative b minus 4ac, negative 2a and negative b, so it's 4h I'm going to simplify a little bit. 14 minus 12, or 16, yeah, 16 minus 12 is another 4. So it's 2h. Okay, so you have a 2 positive solution. When you choose positive sign, just h. When you choose negative sign, it'll be 2 over 6. That's 1/3 of h. Okay. So there's only one critical number in the interval from 0 to h. Okay. So the critical number little h is going to be 1/3 the capital H. Okay. Inside the interval, inside 0 and h. And then clearly volume has maximum value at h is going to be 1/3 the capital H. So we determine the h. You can determine you can determine r, right? So let's go back to the identity. What is that? So this is r, right? I is going to be capital R divided by h. H minus little h, right? So let's see what we get. That'll be 2/3 and h times r over h. So h cancelled out. That will be 2/3 r. Okay, now we can get a pretty good picture when it has maximum value. When what happens when as the radius is going to be 2/3 of r. Okay, not too bad. When r equals 2/3, and in that particular case, h is going to be h is a capital S divided by 3. So how do we, suppose you give a cylinder, you want give a cone, you want to cut it to make a cylinder, right? Chop off something, right? And you want to make sure the cylinder has the largest possible volume. How do you do that? You use a machine to hold it, right? And you have to measure, keep the height. Yeah, the height of the cylinder should be 1/3 of the height of the cone. Okay, then you cut the top part, then you cut the side part automatically. Then you get the cylinder with the largest possible volume. Okay. There are also some things you have to design like that. That's already cone-like surface inside. You want to put a cylinder there, and they have the maximum possible volume, right? Hold enough things, liquid. Then you do the calculation. Then you say, okay, I know that. I make sure the radius of the radius is going to be the radius of the cylinder is going to be the 2/3 of the radius of the base of the cone. Okay. In that case, the height of the cone must be equal to the height of the cylinder must be equal to 1/3 of the height of the cone. Okay. So you get a general formula, then you use that. Okay. Now those are the trivial. We say it's pretty trivial, but in reality, in financial institutions or some in some some company, in manufacturing factories. So you probably have to work on some projects, and those are the new stuff you never done it before, right? You cannot find it from textbook, and you solve it, right? I was told that some guy working for the financial institution, he said, well, he discovered some law, for some logic, some equations that to manage the money investment, and he get more and more data, just keep modifying, but you get this for lifetime, so you stay working there for the company for the whole life. You never worry about to be laid off. So it's important. If you look at statistics, ranking, 200 professional jobs in the United States, and you can check that, right, before you choose a career, a major, the top 10 or top 5, whatever. What kind of job there? Now they rank the job, that's because of salary. Otherwise, the physicians in the hospital will be ranked very high. They're usually high salaries than the other professional jobs. But their quality of life is not that's great. Okay, for majority of the physicians, they have to borrow huge loan. So they are at the age 40, they still pay the loan and also pay the mortgage, the house they buy. Okay. So end of the life, sometimes, of course, they're doing a great job. They save people's life. They get up in the middle of the night, at 4 o'clock or 3 o'clock a.m., work in the hospital. But on the other hand, to themselves, this is not a good life because you don't have a normal life. You have to work there in the middle of the night. So this is there's a ranking. Yeah, you can look at. Okay. Okay. So this is a problem. So we have to do. It's optimization problems. Okay. In reality, we have so many different types of problems. We have to optimize the cost, minimize the cost, for example, right? Minimize the cost or maximize the volume or the surface area, whatever. We sometimes we have to involve them calculus. We have to use calculus to find the maximum value and minimum value. If the function you get is not a quadratic function, because the quadratic function we know the graph is parabola. We know where the function has a minimum value or where the function has a maximum value. But like many simple other problems, even the rectangle, inscribed in the ellipse, right? If you want to determine the largest possible area, and it involves a strange function, like radical, right? X times, like this, x times square root of 1 minus x squared over a squared. Okay, and using elementary mathematics, you're not able to determine where, for what value x, the area has maximum value. So the user calculus, it's so simple as long as you do the computation carefully. Okay, and even the function is tellable, you're not able to even solve the equation. But you can use a MATLAB, Mathematica, or Maple on the computers. Just tell the computer, hey, find the max critical value or find the maximum value of the function. If you know how to type the command, you get the answer right away. Okay, so but you have to learn this. The computer is not smart enough to do everything. Just talk to the computer, right? And that will start to do it. And then gradually, eventually, we do that. That just take your command and start to work on it. Just like recently, when you walk home, before you get home, even just talk to your cell phone, turn on my heating. And we get home, the heating raise the temperature already from 60 degrees to 72 degrees. So feel more comfortable when you get home. Okay, this technology is ready there. So just maybe it's not your apartment. It's not all mass computer. Find expressions for the area, then you can use existing programs or even graphing calculator to figure it out to the maximum value. Okay, but in the future, okay, and the computer is getting fast, and you can write very complicated programs, and the computer can do lots of work for you. Okay, so so my opinion. Yeah, some area like a big data, this kind of computer science, this kind of job will, last forever. All right, so let's take a quiz. Okay, I will give you enough time.